Okay, good morning all. Let us start now because it's getting time later. Then it may be a problems like, so I see some couple of people has come up already. Okay. Anyway, good morning on this beautiful Sunday. And we have a beautiful climate in Bangalore. So I guess all can hear me. Could you please confirm it?
Yes, sir, we can hear you.
Thank you very much. Thank you. Good morning. Good morning all. And more
Good
people
morning,
are
sir.
coming, but anyway, we need to start it because it's already 11:10. So the meeting, I am trying to plan it for at least 1 hour or maybe 1.5 hours, something like that, not more than that. Anyway, so let us straight away go back to the topic. Today's topic is TCP/IP protocol suite and IP addressing. I was providing like many sessions. I was just taking it in the last weeks. Every Sunday, I try to make it up some new chapters as well to talk to the people. I like very much to talk to the people. So now, so what are the technologies which I prepared and what are the technologies which I'm working on? Like, so I would like to share it with the people. So I have started doing this on every Sunday, and after a week or something like that, you'll be able to see this video which is appearing on my YouTube channel. You can able to see that one, and in between, I will just try to share you all these recordings and other things. I do the recording of this. So these recordings, you will be able to get that by in after finishing this meeting or something like that, maybe like around 1:30, 2 o'clock, we'll be getting these recordings as well. And I'll share it with all the groups as well. So how I shared for this meeting info also. Okay, that's about some of the introductions. TCP/IP protocol suite, we've been talking about this for TCP/IP for last 50 years or more than that. What is TCP/IP? What is IP addressing? What is a protocol? What is suite? Why does it call as a TCP/IP protocol suite? How do we utilizing this TCP/IP protocols, you know, and how we are going to work out with this TCP/IP and how do you understand this TCP/IP? Why we require a TCP? Without TCP/IP, what will happen? With the TCP/IP, what all things are happening? I can just say we are talking to this through over this meeting because of the TCP/IP is running. TCP/IP means Transmission Control Protocol, Internet Protocol. There are two major protocols in that suite as named after this TCP/IP. It's an open standard. Anybody can take up this protocol and they can integrate it with their operating systems or any hardware, software boxes and everything. It's possible. So this TCP/IP protocol suite has been developed by some people and it's been given to the all over the world, and everybody started, building on this, like integrating into their software and hardware on this one, so that the communication can happen between the two systems. Two computers can happen through the communication systems can happen through the TCP/IP only. Transmission control protocol, which will be handling the transmissions of the packets between the two different systems and remote systems. IP will be giving you the IP addresses for to identify who is sending it and who is receiving it, like source and destination IPs, which we will be receiving it by the IP protocol. Protocol is, what is a protocol? Protocol is like, it's like a set of algorithms written, set of programs has been written to do certain operations like that. That is a protocol. Protocols normally, which is English word, like a protocol means we'll just following some set of rules or something. The same way, I can just say the protocol is like that, an IP protocol, TCP protocol, UDP protocol, like many other protocols are there in the suite. Suite means it's like a suitcase like that. We keep all the protocols inside on this. So that will form a certain operations for to run your own applications as well. And you can able to talk to the other peoples as well. You can share your video, you can share your audio. Like media streaming is possible on this. And addressing patterns has been given on this particular protocols. And every other application has got its own protocols are assigned for that. Say, for example, I can just say HTTP for web surfing. We are all using the HTTP protocol, hypertext transfer protocol. And we are all using the FTP protocol to download certain files from the internet. Or we can even use that FTP for to upload certain files or something to the internet sites and all. That's possible. SMTP we are using, SNMP we are using, POP3 we are using, IMAP we are using, and DNS we are using, SSH we are using. like telnet we are using every protocol, whatever you type it out on the networking field or in any computer field, when two networks are going to talk or two hosts going to talk or server is going to talk to the clients or something, we require the TCP/IP protocol suite has to be implemented on all the boxes wherever it is running. Then only we will be able to talk to each other, and we can able to share some other files, and we can able to collaboration is possible, voice is possible, video is possible, everything is possible because of the TCP is there in the market. TCP/IP has been integrated in the all the operating systems like Windows operating system, Linux operating system. In the Cisco platform, I can just say internet working operating systems, and even in our Android phones, it has been operating. And in iOS phones, Windows phones, I guess Windows phones are still there, maybe gone. Every phones will be having that IP protocol, so it has to be there. Then only you will be able to connect to the internet by using this, TCP/IP. So TCP/IP is inseparable from our life, daily life. So without TCP/IP, we will not be able to talk to anyone. We will not be able to communicate with anyone. Like WhatsApp, we are doing that. We are doing the Telegram, and we are sending some mails to the people, and we are chatting on the Facebook or something, and we're putting some status on the Twitter. Everything is possible through the TCP/IP protocol stack. What does it do? What do we require? How do we configure? Like it has been already integrated. We are just going to fine tune it, and we will be configuring it for our own, our own requirement or something like that. So how we are going to configure this protocol, and what is the best of the practices which we need to do when TCP programming has been done, and what all the technical terms will be involved in the TCP configurations, and how what all the technical jargons are involved in this, abbreviations and other things which we see. TCP is a transmission control protocol. IP is internet protocol we call. Internet protocol means the name which was internet was something different at that time when it has been invented. Now the internet, we talk about our internet, where we are connecting to the all the social networking platforms, and we are talking to the sending the email to the people and other things, and we are talking on more on cloud and other things. So these all, that is possible through the internet protocols only. So that's what we are discussing today. Okay, somebody is joining. 1 second. Yeah, they join now. Okay, nice. So I see people, a couple of people are coming more. Anyway, we will talk about the TCP/IP protocol suite and IP addressing. Why I am very much stressing about this TCP/IP protocol suite in the sense, whoever is coming into the computer field, either he may be a software programmer, or he will be a technical support guy, or is a hardware guy who will be assembling something and selling it, or he will be maintaining some of the systems, maintaining a firewall, maintaining a load balancers, maintaining the entire network, servers and the other operating systems, and some applications. Whatever he is going to do that is possible through the TCP/IP only. Because of that, if you have the proper understanding of the TCP/IP protocols and the entire suite, it's very easy for us to work with the multiple platforms as well in the computer industry. That's why I'm stressing about the TCP/IP protocol knowledge has to be there for everyone, so that you will be able to work freely and without having any kind of troubles or kind of understanding problems with understanding the entire network or something. So that is possible through the TCP/IP protocol suite only. So TCP/IP was there, as I told you, like around 50 years it has been there, and we are having some kind of an upgradations are also happening. Earlier, no, not only earlier, still we are also using the IP version 4 protocol, you know, and IP version 4 means it is giving the IP addressing schemes on certain format, decimal format or binary format something. And IP version 6 has come up now, so it's come up now in the sense it has been introduced in 96 only, but still we are implementing it. Lasted 2-3 years, there are IP version 6 implementations have started, and it will be in a full swing by 2025 because we are losing all the addresses on the IPv4. Okay, so the IPv6 we will be discussing lately about the IPv6 also here. So I will be discussing on the more protocol suite here, addressing schemes, and every application, whatever the protocols which are doing our application protocols and other things. These are all we will be doing on this particular session. And at the end of the session, I would like to show you some IP addressing and subnetting very important. That is what I just given the IP addressing and subnetting, which we are doing that. And these are all the things we'll see, that a class C is subnetting, class B subnetting, and class C is subnetting also will be doing on this the session today. So it's a very basic for everyone. Everyone should be understanding this IP addressing schemes and subnetting schemes, especially for the people who are supporting the customers on the networks and other things. Either he is a normal person who is supporting the people of the application side, or even a database person, or even maybe like the person who is supporting the system administrators are there, network administrators are there, security administrators are there. Everyone should be understanding the TCP. Then only you will be able to work on the systems. So it's easy for us to troubleshoot it, and as well as to make the system up and running for us. Maintaining, troubleshooting, implementing, designing, planning, everything you require to know about TCP protocol suite. Okay, let me make my screen bigger and I will share it out. I guess it's already been shared. And let me make it bigger one so you will be understanding this. I'll make it as F5. F5, okay. So TCP protocol suite and IP addressing, this is what we are going to discuss it today. History and future of TCP/IP. US Department of Defense, DoD, created the TCP/IP reference model because it wanted a network that could survive any conditions. Some of the layers in the TCP/IP model have the same name as the layers in OSI model. We will discuss the OSI model and TCP/IP model. Because this session is we are talking about the TCP/IP, so I am talking about the TCP model first. Top layer, as usual, it is an application layer. Then the transport layer. Transport layer will be transporting the packets between the systems. Like it's like a courier service, it will be doing it. Then the internet layer will be giving that IP protocol, all the routing protocols which we are working on, all the network engineers must be knowing about the networking protocols. They know about all the internet layers. Network access layer means, in a comparison, if we just do that, we can compare it with the data link layer and physical layer, all the network access. So here in TCP/IP protocol suite, we have only 5 layers designed. This was a design previously on the first time. Still it is the same layers only on TCP/IP. And let's go to the next slide. Comparing the OSI model and the TCP/IP model. In the left hand side, you can just see the TCP/IP model, and the right hand side we are just seeing the OSI model. In the OSI model, we have 7 layers. Everyone knows that as an application, presentation, session, transport, network, data link, and physical. There are 7 layers of that. In this top 3 layers, 765, we call it as an application layers. Let me admit someone. Okay. Sorry, I just admitted them. Okay, next 765, the top layers which are called as, like, I can just say it's an application layers, and the down 4 layers are there, 4, 3, 2, 1. Those are all called as the data flow layers. It has been called an OSI model. We are discussing something about the TCP/IP model. So application and the transport, here it is called as the protocols, and internet and network access, it is called as a network layer, like this. So this is the comparisons about that. In TCP/IP model, we have only 5 layers. In OSI models, we have 7 layers. OSI reference model, we will discuss it, then we will come back to the TCP/IP model, because most of the people knows about the OSI model only. But OSI model has been derived from TCP/IP model. Okay, OSI is nothing but open system interconnection. This is a reference model, providing the general framework for standardization, defines a set of layers and services provided by each layer. One or more protocols can be developed for each layer. And it has been developed by the ISO, that is called as the International Organization for Standardization. Also published by ITUT, International Telecommunications Union. Some more person is joining. Okay. OSI, this is a OSI reference model example. Like there is just an introduction of it. I'm just going to the next one. Similarities between the OSI and TCP/IP models. Both have the layers, definitely. Both have application layers, though they are including the very different services. Both have comparable transport and the network layers. Packet switched, not circuit switched technology has been assumed. Network professional need to know both the models. Definitely, you should know the TCP model as well as you should know the OSI model. And why we are going for OSI in the sense it is for an open system interconnect, means multiple devices, multiple vendor devices can talk to each other. That's why we are talking about the OSI model. Means like a Dell PC can talk to the Cisco switch can talk to the checkpoint firewall, like that. So different vendors can talk to each other when there is a network has been built by the multiple vendors. So that's why networking professionals need to know about the both the models, OSI as well as TCP models. Differences. TCP combines the presentation and session layer into an application layer. TCP combines OSI data layer and the physical layers into one layer. That is called as a network access layer. We seen that. You see this here, networks layer, and this is a protocols layer. And the TCP appears simpler because it has got fewer layers. TCP protocol layer using UDP does not always guarantee reliable delivery of packets as the transport layer in the OSI model does. Okay. So it depends on UDP also, but does not guarantee. Yeah, anyway, but in OSI also we will be discussing all these things, TCP and the UDP models as well. Okay. And the next one, OSI environment. How the OSI environment has been built. You can just see this on the left hand side, who may be the sender, and the right hand side you can just see that the person who may be receiver, he is a sender and he is a receiver. From the application the user data has been constructed, and there is in the presentation there are some PDUs, or PDUs means protocol data unit, they are getting added on that transport layer. The transport header information has been inserted in the sense what all the segments are going to be, how many packets are getting transferred, what is the window size, either it is a handshaking packet or a original packet or something. Then it will be adding that network layer. In the network layer we will be seeing the source IP address and the destination IP addresses will be header will be added. On the network layer, on the data link layer, we'll just see that it will be the MAC addresses will be added to that. The source IP, source MAC address and destination MAC addresses will be added. And on the physical layer, it'll be converted everything into the electrical signals like one and zeros and all that. So this communication is happening through the like the path, like this point-to-point link, something like that, and it goes on. When the receiver receiving the packet, he will pick it up all the bits and bytes, and he will translate it to the data link, and he'll remove the network layer, and he'll remove the transport layer headers, and he will remove session and everything. Then the user data will be like produced to the receiver. So all the other control informations will get removed as soon as it is passing to the next layers. So that is a OSI environment. How does it work? When a sender is sending a packet, he will be attaching all these necessary informations so that it will be reaching the intended partner. From the internet, if you try to download any file or something, it tries to exactly reaching your PC only. How is it possible? Because of this proper headers are framed. Proper headers are attached to the headers and trailers. I can say headers and trailers are attached to the environment so that it is being constructed properly and it has been delivered. OS layer, it's a physical layer, is interface between the devices, mechanical and electrical specifications we talk about in the OS layer. In the data link layer, we will be talking about something on basic services like error detection and control, flow control at the link layer. Like later the sub layer as a data link layer, media access control. That is where we will be receiving the MAC addresses from this and to deal with the broadcast networks and all. This is the OSI layer, the physical and data link has been designed. Network layer, in the network layer, we will be getting the routers and other people will be sitting on this, the devices, and the transfer of the information through the communication network. Network related issues are handled by this layer. Network nodes should perform switching and routing functions. QoS, quality of service, and congestion control are also discussed in this layer. Several other internet networking issues like addressing part, maximum, and data length, and other things are all. Like OS layer in the network layer means we will be mostly concerned about that IP addressings given by the IP protocol and the routing protocol. There are so many routing protocols there. RIP, IGRP, AGRP, OSPF, BGP, you know, and like that, many other protocols will be keep on receiving that. So those things all being handled by this network layer, and not needed on direct links means direct links will be handled by the physical layers only. It's been written like that. The next one, layer 3, OSI layers number 3, transport and session. Transport layer, we will be having the end-to-end exchange of the data in sequence, no losses, no duplicates. If needed, upper layer data split into smaller units, definitely, because if I'm sending the 10 MB file in a stretch, it's not possible. So in one shot I cannot send the 10 MB file, so I'll be making it as a small chunks and I'll be sending it. That is what splitting into the smaller units. Session layer, it will be for the session which we are conducting is called as a session now. Control of the dialogues, who's turn to talk, dialogue discipline, whether it is a full duplex talking or half duplex talking, something like checkpointing and recovery. And session layer will also be doing a lot of other work, making a session, breaking a session, resuming the session, and terminating the session between the just session in the sense when you try to do the telnet or an SSH to the device entire, like remote device. At the time, you'll be making a session that's been done by the session layer, breaking a session, and resuming it again back. Then terminating means you'll just log out and come out. Like all these are maintained by this session layer. And the last one, we just need to discuss about the presentation of application. Presentation is the data formats and the data compression and encryption. Data formats, which we talk about that all the how the data has been presented. We are all using the coding format, EBCD code, ASCII code, Unicode. Those are all data formats. Data compression, which we talk about something zipping, roaring, and we are all doing that. That is nothing but a compression techniques. Encryption in the sense like in the security topics, we'll be discussing about the encryption standards. What are the encryption standards? Data encryption standard, triple DES, advanced encryption standards, like many other standards are there. Those are all being, presented in the presentation layer. Then the application layer and support for various applications like HTTP, SSH, Telnet, SMTP, DNS, so many other applications are there in this application. Then we'll talk about the TCP protocol suite. Most widely used interoperable network protocol architecture, specified and extensively used before OSI. OSI was slow to take a place in the market. Funded by the US Defense Advanced Research Project Agency, DARPA, for its packet switch network, ARPANET. DoD automatically created an enormous market for the TCP. Used by the internet and www, we are all using only the TCP protocol in the internet. So just think of the world without TCP, the internet will work or something. Not possible. Okay, so this is most widely used interoperable network protocol architecture. Definitely, we are all using that. Every other operating system is using the TCP now. Windows operating system, Linux operating system, iOS, Android OS, Apple OS. Everybody is using that. Okay, then we will talk about TCP does not have an official layer structure, but protocols imply one application layer, transport layer, internet layer, network layer, and physical layer. Actually, TCP reference model has been built on its protocols. That is why the reference model is only TCP protocol suite. And this is why it is not so important to assign roles to each layer in TCP. Understanding TCP and application protocols would be enough. Means how do they work, where they are working, what is their job, and what they accomplish at the end of the day. This is what make more sense about the TCP rather than just looking for the layers and all that. So when you thinking about that SSH, how does it work? It should be working from the application layer, correct? When I'm giving an IP address to the people like that, in the sense I can think of it as an internet layer like that. So we just need to understand where the protocol fit into that and what operation it's doing it. That makes more sense. Network access and the physical layers. TCP/IP reference model does not discuss these layers too much. The node should connect to a network with a protocol such that it can send IP packets. This protocol is not defined by TCP/IP, mostly in hardware, and well-known example is an Ethernet. So we are all depending on the Ethernet to send the packets out. So there are a lot of Ethernet technologies out there. Like we are using some different speeds in the switched networks, 10 Mbps, 100 Mbps, 1 Gbps, and 10 Gbps. Everything has got its own standards, 802.3 something. Every other network will be coming up with that standards. So internet layer, Here, internet layer is very important because the IP sits in this layer and all the routing protocol sits in this layer. Connectionless point-to-point internet networking protocol using the datagram approach takes care of routing across the multiple networks. It's very important. Takes care of, yeah, see, this is what routing across multiple networks. Very important word. And each packet travels the network independently of each other. They may not arrive or they may arrive out of order. It depends on that. How do they getting delivered on this? More flexible and responsive to lose some other subnet devices. Someone else is joining. Okay, they joined. Implemented in the end systems and routers on the as the internet protocol. No, it's not going. Sorry. I tried to remove this one. Let me clear this. Okay, now it's clear. So let us go to the next slide. Transport layer, end-to-end data transfer, transmission control protocol, TCP, connection oriented, reliable data delivery, ordering of delivery, sorry, ordering of delivery. And in the transport layer, there are two layers, are two sub protocols which we are going to use at every time. Either it's a TCP we will be using it, or it will be the UDP we will be using that. TCP means a transmission control protocol. UDP is nothing but a user datagram protocol. What is the difference between these two? Transmission control protocol will be giving you the connection oriented delivery. Means it will be keep up the sequence numbers, acknowledgements, and it will make the connection possible, and it will be like a connection oriented, and it is a delivery will be reliable. It will not drop any data. It will not drop any packets at all. If I am sending the 10 packets to the receiver, if the receiver has received only 4 or 5 only, then he will be asking for a retransmissions. The retransmission is initiated by the TCP protocol, and the TCP protocol will be from the sender. The TCP protocol will reinitiate the traffic again. Means that 10 missing packets will be sent back again. That's why it has been called as a reliable delivery of the data. And ordering the delivery in the sense order, which order it has been like presented, which in which order it has been sent out. Like as I said that if I am sending the 10 MB file, or I just take that like because we are all downloading some of the movie files from the internet through the micro torrent or something like that, we are just doing that. When we are downloading that, maybe like the movie file minimum it will be like around 500 MB, or maybe like 1 GB if you are taking the file as in 1080p. So it will be like 1.2 GB or 2 GB, something like that. None of our speeds, whichever we are using in the home or maybe in office or maybe like the mobile which we are using, that it cannot download the 2 GB, like directly. It's not possible. So what we do normally, that file will be segmented into multiple parts. 2 GB file will be segmented into multiple parts. Means in the sense, it depends on the link capacity which you have it at the endpoint. Maybe your speed might be a 2 MB speed, or maybe you are having only 500 KB speed, the receiving speed I'm talking about. So accordingly, the TCP will be making a small chunks of the 2 GB, maybe like 1 MB per chunk, or maybe 1.5 MB per chunk, or maybe 500 KB per chunk. So according to the link capacity of yours, the chunks will be reduced, means like contracted, or it can be increased. Like, okay, so that is an increasing and decreasing is possible. Means the way that we are going to receive that packet to our PC. Because of that, when there is a heavy packet is coming, in the sense my link will not withstand. It will be disconnecting it. When it is disconnecting, in the sense your file will go corrupted. So the TCP will not allow that. By calculating the link capacity all over the network, and it will find out that in which speed you can able to receive the packet, so that it will be start contracting the size of that. That is called as a window size, we call. In the window size, it will be like if a receiver is able to receive only 5 windows per time, in the sense, and the sender is sending 10 window size per per communication or something like that, he will reduce it. He will reduce it to 5 size, because of that receiver cannot hold it. He cannot buffer it like that. So when there is a link capacity is coming up more, like when it can have more, like then the receiver may be saying that I okay, I can receive 10 or 15 packets also at a time. Like, so at that time, it will be enlarging the packet, enlarging as well as contracting the window size, and it will be keeping the, like what is it, the point, it will be keeping that the how many packets has been sent on this, and those by delivery of the packets and other things, it will be keeping that sequence numbers and other things. Through the sequence numbers, it understands that how many packets has been delivered and how many yet to be delivered and how many are missing, so that it can go for a retransmissions and other things. So this much informations are done by, this much operations are done by TCP. That's why it is called as reliable delivery. That's why it is called as reliable delivery. This is very important. In TCP communications, we just need to understand that TCP will give you reliable delivery and the connection oriented, and it is ordering the delivery. 3 points are very important when we are talking about in the TCP, because we are having the synchronize and acknowledgement will go off. Sin acknowledgement. I'm just writing like this. Just hold it. Sin and sin acknowledgement can go on this, and the window size it takes. It's a window size will make sense, and there is a sequence numbers which comes on. So these are all the plus points of the TCP communications. Okay, that's why we are depending on the TCP protocol for when we are transmitting something. Like all your FTP transmissions, HTTP and other things, everything is be working on based on TCP only. They will depend on the TCP to talk. And we have one more UDP is also there. That UDP is nothing but user datagram protocol. User datagram protocol, it is a connectionless service. Very important, connectionless service. And delivery is not, please make sure, delivery is not guaranteed. In the sense, whenever it is delivered. If it is not delivered, you are the person to reinitiate the connections. Means manual intervention is required when the packet is not getting delivered or something. When we are pinging somebody, the ping is actually using the UDP only. The ping packet whichever we are sending there, that is being used by the UDP only. That is being, sorry, ping is means like an ICMP. ICMP uses the UDP. Okay, so connectionless service, and the DNS is used, DNS translations are happening through the UDP only. Means whenever I am typing that in the any browser, HTTP facebook.com, first time it's saying that the page not found something like that. Then what I do, I will just press F5. F5 means refreshing. When I'm refreshing again, it's happening. So when I'm doing the refreshing, it's nothing but the manual intervention of the reinitiation of the communication between me and the server. So that is being done by the UDP. Means like the DNS translations I was telling. DNS translation is nothing but domain name service. Domain name service is like an IP address to the name to the IP address translations or something. That has been done by the UDP. A good example is the DNS and the ICMP. Okay, and the protocols ICMP which we are using, the trace route command which we will be using, that is using the the UDP only, and the ping command which we are using, that, and the ping is also been used by the UDP only. So the delivery is not guaranteed at all. So what the application layer protocols will do when there is a critical transmissions has to be happening, means when you are downloading the 2 GB or 4 GB file from the internet or something like that, that time definitely the application will choose a TCP only, because the main intention is that the file should not get corrupted at all. When we are doing some kind of name resolutions or pinging or tracing, or which doesn't require any kind of a critical transmissions between the user and receiver, as a sender and receiver, that time we will be using the UDP. So please remember that. Okay, somebody is raising the hand. Yeah, you can ask me the question, no problem. You can unmute your mic and you can ask me the questions. Yes, sir. Vinay, huh? Tell me, yeah, Vinay, what's your question, please? Ask me.
Yes, sir. I was asking that some download doesn't support resume, so it will be UDP or a TCP.
No, not that way. It depends on your application which is supporting that. Maybe the server may not be doing the reconnections like other things and all. Because why they do that reconnections are not possible with the same machine or something. There will be
Yes.
a chance of getting attacked again. Means the spammer attack may be there, virus attacks may be there. So that's why some of the
Okay.
servers will not be supporting on that. That application which is being put on that server, it doesn't support any resuming the connections or something. So it happens like that is because of the security measures. What I am talking in the ground root level, like user datagram means it will not be using the UDP. UDP will never use the UDP for to like receive or send the traffic. That is not at all possible. use the TCP only, but they will be restricting that not to resume the connections or something on the server side. That's why we will not be able to get that. I
Okay, sir.
guess
Thank you.
I answered your question. Maybe like if you go for a Google Drive or
Yes.
something, it may not support that. You know.
Yes.
Uh, and if you go for a torrent is a complete different architecture. I can discuss about torrent later, but not now. Because
Not
torrent
now.
is
Yes.
actually picking the files from everybody else whoever is already downloaded. It's like it's an illegal application actually. So
Yes.
that's not recommended at all. But some of the sites which are giving again, some of the sites are which is giving again the through the torrent also it is possible. Means torrent in the sense what they do, they will be putting that file, that original file maybe like they will be putting in some mirrors. Mirrors in the sense maybe like original file will be kept in one location and there will be 10 to 15 mirrors they will keep it. Means a copied files will be kept on somewhere. Whenever you are doing the torrent application when you are starting them, your torrent client will be talking to those 15 servers and it will be downloading the file for you so that you will be able to download it faster and you can utilize your bandwidth very efficiently. That way it's
Yeah,
supported.
using a nearest mirror or something like
Yeah,
that.
right. Okay. Somebody else is asking some Hassan somebody. You can ask me, no problem.
Yeah,
Yeah.
yeah. So if we stop any downloading and then we change the internet connection, it will not resume from that place only. It will start again. So
Ah,
because of the connection has been closed and the connection has been re-established again with the new server IP address. So because of that only.
yeah, see, your question, I can answer it in that way. Like, because when you are connected whenever we are connecting to the internet, we are connecting through either Geo or maybe like Airtel or Vodafone or something like that. Either you will be connecting
Hmm.
through your Android phone or iOS or maybe like Windows system only. Whenever you are connecting,
Hmm.
you are like a dial-in user only. You are a temporary user. Whenever you are connecting to the internet, that time there is one public IP assigned to you. That is only temporary. Temporary in the sense,
Hmm.
at the time of connection only you can utilize that. Once the connection terminated due to any conditions, maybe like your phone is
Hmm.
out of range, or the 4G connection got cut, or you are crossing some other boundary, something like that. So at that time, what do? You will get disconnected. Means the IP which you given to you has gone to someone else. Then you are reconnecting again. There is a new different IP has been given to you, public IP. When you got the new
Hmm.
public IP, when you try to like resume the same connection again, server will not respond. The server
Okay.
is try to get the same IP information only from you so that the connectivity can be maintained in the same stretch. When you have a disconnection from your side or from the server side, IP getting changed. That's why you are not able to resume the connections. So if you are working in a company and your production network, if you try to install or download or something like that, because you will be having the static public IP will be assigned to you for your network or yourself.
Hmm.
That time you will be able to
Hmm.
resume the connections, and that is also coming into the like some of the points like that. The server need to support resuming connections. Then only you will be able to download it. That is also important.
Hmm.
So
Okay.
that is what happening actually. Okay.
Hmm. So if server is not supporting that connection, it will start again, no?
Definitely. You need to finish the
Okay.
transmission completely in one shot. If the
Okay.
server
Okay.
is
Okay.
not, if the server is not going to, supporting the resuming the connections or something. Yeah, this is a good question. I was just expecting. Nice, very nice. Any
Yeah.
other questions regarding this downloading another thing from anyone else? Please ask me, no problem. This is a interactive session because TCP/IP is very basic for everyone should be knowing that. That's why I'm just starting this chapter. It's not a so high fun thing. Last week I was talking about some application security module and other things. Very heavy. But this is a TCP. We can ask any questions. No problem. Any silly questions, okay. Because I was just looking for any people who has to be interacting with me so that I will also be much enjoying and talking to you people. Tell me, no problem. Any questions are okay. So, okay, if no questions, I can pursue with the next chapter. Okay, means the next slide. I can just go there. So, can I give the example application? That's what we were just seeing that. Example is nothing but the ping we can do, and trace route we are doing that normally, and the DNS applications which we are using that name resolutions and all it will be happening through the UDP only, right? So that was the thing. And the next slide, go to the next slide once again. Application layer. So support for user applications. separate module for each different application. That's what I was telling you. Like HTTP is one of the application. SMTP is for simple mail transfer protocol. We are all sending the emails to everyone, Gmail, or maybe like inbox from your inbox, or from your mail server you are sending the mails. Everything is through the SMTP only, telnet. And I can give some more examples also on this. Like many other things are there in that. SSH I can say one other protocol, and telnet has been already given on this. DNS is another one, okay, and rlogin I can tell. Rlogin is one of the protocol which we normally do. That is for Unix to Unix communications, and all we'll use rlogin. RDP, people will be logging into the Windows device like Windows servers from different locations. Remote login, that is on a remote desktop protocol. These are all coming under the application layer we talk about. So these are all the applications like that, you can just say. So this is about that, and we'll go to the next slide. Internet protocol. So it is important. You don't need to know that what is the frame of the packet, how does it been formed, and how many bits has been utilized, and all these things. If you are not a programmer, it is not required. But if you are a TCP/IP programmer and you do you are constructing a new application for your organization, and you would like to make the TCP/IP to talk, because without a TCP/IP transmission is not possible. So you just need to make all these settings properly. So you should understand what is the IP protocol and how the packet is getting organized. Like the core of the TCP/IP protocol suite, internet protocol, definitely. This is a core, definitely it's a core only. And two versions coexist. There is a IP version 4 and IP version 6. There are two versions are there in this. Sorry. Let's come to the next slide. So this is the IP version 4 we are talking about, IPv4. We normally work on IPv4 only, and IPv6 also there. The pen is not working properly. Okay, IPv6 also there. It is built on C. It is IPv6 already been in 1996. Still we are deploying. It's near about 24 years it has been there in the market. So IPv4 header is minimum 20 octets, 160 bits. Octet means 8 bits. Octet, yeah. Yeah, octet means 8 bits. 20 into 8, it will be like 16. So 160 bits it will be coming up like. So this is the packet format. How does it look like? The IP header will be like this. It's a first is a version, IHL, DS, ECN, total length, fragment set, header checksum, is identification of the time to live and protocol. Whenever you are pinging a particular IP or something like that, you will be getting the TTL value. That is called as the time to live. Source address and the destination address. Source IP address and the destination IP address. These all informations are built in the IP packet. So you can just know that, because it is a, like what I say, it's a knowledge for you. But if you are a programmer, you should be knowing this. So total IP packet is how much at the length? It is 20 octets. We just say it in a 20 octets, or we can just say 20 bytes, 20 byte of information on this. And let me go to the next slide. TCP, transmission control protocol, end-to-end protocol is reliable connection, providing the flow and error control. Flow and error control is nothing but that we are having the like what is that mechanism which we do, the three-way handshake we normally talk about. Three-way handshake. What is the three-way handshake? SYN packet is sent and acknowledgement will come up, then the establish will be happening. That is a three-way handshake. When SYN will be sent by the receiver and the acknowledgement will be come from the sender, establishment will go from the sender to the receiver to the sender, means the communication will be done. SYN packet contains that how much byte I can hold, what is the size of the packet I can receive, what should be the window size for that, what is the sequence number we can start with that, what is my speed, and what is my bandwidth which I can withhold on something. All the informations will be coming up on the SYN packet. So the SYN packet will be containing all this informations. Once it is synchronizing, it is actually synchronizing. We are saying SYN packet, synchronizing it with this sender. Synchronize goes from the receiver to the sender, and the sender will come up with the acknowledgement. Okay, I am acknowledging with your speed and your bandwidth and your window size and all these things. Whenever it is saying acknowledging, then the receiver will be sending back the establishment packet. When established, in the sense, the two stations can talk to each other based on the standards which they agreed on this. And that is what the reliable. That is for the flow and error control. Error control is nothing but retransmission. Retransmission, whenever it is required, when it is required, the retransmission requires when there is a packet loss is happening. Packet loss, when it will be happening, the packet loss. Packet loss can happen whenever there is a spurious signal has been there. Means when you are traveling in a bus, when you are traveling in a train or something like that. When you go across certain place where there is no much signal at all, your signal is getting very much reduced. At that time, when you are trying to receive the 10 packet, you may be receiving only 2 packets because the connection is not so stable. So when you are receiving 2 or 3 packets only, what your application, receiving application will do, oh, I just need to receive because we agreed on 10 packet per the window size, right? But I received only the 2 or 3, that's it. So remaining 7 I require. So the remaining 7, for that it will require a retransmission. That retransmission is nothing but the error control. Error control in the sense, TCP will be informing the application again back in the top layer. We just need to send the packet out back again. So I am just sending the packet again back like that. So this all happening on fraction of seconds. So flow control and error control, both done by the TCP. That's why the TCP is called as reliable connection. Reliable connection. Your connection will not get disconnected at all unless your physical connection is disconnected or something. So in TCP terms, a connection is a temporary association between entities in different systems. Definitely, sender and receiver is not going to be in the same place. Maybe the sender will be there in the US, the receiver may be there in Bangalore or Chennai somewhere. So that is a different systems as well. Even if you are sending it from the one station to another station also, even in the same local area network, in the same building or same floor, you are sending it to your friend. You're just saying hi. Maybe like so. That is from the different systems itself. Two different protocol stacks are talking to each other. So that is called as the TCP terms, it's called as a connection. And the TCP PDU means a protocol data unit. That is called as a TCP segment. Segment is nothing but like chunks. We say chunks. Chunks of data is called as segments. Chunks. Okay, chunks of data is called as segments, and including the source and destination port. What is the port? Port is nothing but like it's carrying the information about that. What is it carrying? And what application is working on that? Which particular application is running? Either if it is a HTTP means we will be using the port number 80. When we are doing the FTP means we will be using the 21, 20 and 21 will be using that. When I'm sending the mail to the people in the sense, I'll be using the port number 25 like this. This is the destination port number. Please make sure 80 is the destination port number, but the source port number will be of anything from the dynamic. Maybe like it's after 1024 something. So port number total port numbers are this much: 65535. Out of that, until 1023 is the what do you say? Well-known port number. After 1024, it is called as a dynamic port number. So under the well-known port number, we all have all the protocols are set. Means it is a HTTP applications, FTP application, SMTP, DNS, everything will coming under that. So that is nothing but the source and destination port the segment will be containing, and it is identifying the respective users, means applications. Pair of ports together with the IP addresses uniquely identify a connection. Means like say 1.1.1.1 is a destination system. So port number I will give it as 80. So now what I'm doing it, my destination IP is a 1111 and it is the protocol which is running is an 80. Means maybe this server will be running a web server application. So in that web server I am contacting that, so I just need to have the destination port as 80. That is what has been written, para ports together with the IP address. This is an IP address and this is a port number which I am giving. And such as identification is necessary in order to TCP to track segments between the entities. By using this IP address and port numbers only, and source and destination ports only, it has been identifying the entire channel of information. Okay, let's go to the next slide. TCP header will be looking like this. Again, some information. 20 octet. This is also 160 byte, 160, like 160 bits, something like that. It goes source port, destination port, sequence number, acknowledgement number, and the checksum, which goes on everything on checksum. This is based on checksum only retransmissions will happening. And the window size, here the window size is urgent pointer is again deeper, you can leave it. Window size is nothing but like that, how many packets can be sent at one time. That is a Windows packet. That is a Windows. So here the 20 octets, IP header is also 20, TCP header is also 20. So person who are working on programming on TCP can maybe knowing this, okay? Anyway, UDP. How the UDP is looking like? Universal Data Protocol, alternative to the TCP. It is also an end-to-end protocol, but there is no guaranteed delivery. That is what important. No guaranteed delivery, not a guaranteed. No preservation of the sequence. It doesn't keep any sequence numbers at all. No protection against duplication. Maybe the packet will be sent back again, which has been already sent. It is possible. Minimum overhead. Okay. Then why we are still using that? We will use it for a pinging, trace routing, DNS, which all non-critical applications. We will use the UDP. For non-critical applications and all, we will use the UDP. This has got only 8 octets. Source port, destination port, segment length, and checksum. Very simple. It's got only 4, there we are using the 20, here we are seeing only the 8. That's why you just come to know that how much important the UDP is. Next, PDUs in TCP IP. In TCP IP, how does it, the packets are getting, added with the headers and trailer information to the user data. In the application byte stream, we have only the user data. When it is TCP, it is adding the TCP header information. In the TCP header information, it will be having the destination port, sequence number, checksum, source port, everything will be there on this. Then it comes to the third layer. This is the, you can just say application layer or something like that. And the TCP layer means it's coming in the transport layer. From the transport layer, when it comes to the network layer or internet layer, you can just say. In the internet layer, destination address and source address has been added extra. IP addresses. With the IP addresses of source address and destination addresses, these destination ports, source port, sequence number, checksum informations, everything will be added to that. Then it comes to the network packet layer. There we will be having all the MAC address and other information will be added to that. Operations of TCP IP. This is a host A is talking to the host B. Okay, and application Y and application X. Application Y is talking to application Y. Application X is talking to application X. They are talking through the port numbers only. This IP will be giving you the addresses of the sender and receiver, host A and host B. Network protocol access, here it is coming, then the physical. Physical goes on connected to the network and wired connectors are there. There's a router has been based on between the two hosts. Network 1 to network 2, the packets are getting transmitted and the communication happens. Means what I try to say, physical will talk to physical. IP will be talking to IP. TCP will be talking to TCP. Means everything has been combined and sent. When it has been sent, physical will look only for the physical information. Once it is understood the physical information, it will remove the header, send it back to the IP. IP will understand its own information, remove it, then it will send it to the TCP. So like that, this is how the packet transmission happens between the two end systems. Some protocols in TCP IP suite. In application layer, what are the protocols are there? Telnet, FTP, SMTP, HTTP, BGP, TLS, SIP, SDP, many protocols are there. These are all based out of TCP. Means these application layer protocols will be utilizing TCP for to transmit the packets to the other system. Like that. All based on IP. IP in the sense it will be giving the addresses to this. And in the UDP using applications are media, RTP, SIP is also using some part of it, DNS, SNMP. These are all using the UDP. And UDP is also talking to the IP as well as. And in the internet layer, we are using the ICMP, IGMP is used for multicasting applications. OSPF, RSVP, many other protocols are there, IS, VC, like BGP will be using that. But BGP is using the TCP communication. So application layer, transport layer, internet layer. In each layer, what all the protocols are sitting, where they are taking the part of it. So that is what been explained here. Here you can just see all the explanations on this. Border gateway protocol, domain name system, file transfer protocol, HTTP, ICMP, everything which we know. Mainly we know that RSVP means resource reservation. This is for like multicast applications will be using the RSVP. RTP, real-time transport protocol. Session description protocol, SDP, SIP, session initiation. This is used in the voice communications. SMTP, SNMP, TCP, TLS, UDP, everything which we know. So these are all the protocols are there in the TCP suite. Next, who is assigning the IP address? We are all enjoying our own IP addresses. When we connected to the internet, we are having an IP address. And we are asking about the IPv4 addresses or IPv6 addresses, something like that. Who is actually responsible for assigning the IPs to us? That is Internet Assigned Numbers Authority, IANA. So ISOC entity responsible for all unique numbers on the internet, including IP addresses. Almost all protocols work with the numeric parameters. Means example port numbers, error codes, status codes, message types, options, and etc. The meanings of all numeric codes are mostly specified in RFCs, request for commands, but number assignment is formalized by the IANA, Internet Assigned Numbers Authority. He is the person who is assigning the IP addresses for us. For us, in the sense, they will be giving it to the internet service providers. From the internet service provider, we are getting the IP addresses. So IANA is the whole and sole authority of assigning IP addresses to the organizations, countries, continents, individuals. Okay, let us come back to the IP address classes. How many classes are there? Class A, Class B, Class C. 3 classes are there, which we will be discussing only 3 classes here. But actually 5 classes are there. D and E is also there. Class D and Class E, right? Class D is used for multicast. And Class E is used for R&D, which we don't require, right? So that's why we are going to discuss only about 3 classes. Class A, Class B, Class C. Class A, we will be having 8 bits of network, means 10.1.1.1 means 10 is a class A. In the class A, only the 10 is a network number and the rest all host addresses. Means if I'm saying 10.1.1.1, sorry, 10.1.1 in the sense 10 is a network number, rest all hosts. That's what we can say. This is a host, host, host. This is network, like this. And in the class B, 2 sets of networks, means a 16-bit network. And in the class A, it's 8-bit network and a 16-bit host in class B. 24 bits because the IP address is totally 32 bits. 32 bits is an IP address. One IP address is cost 32 bits. 32-bit IP address. In the 32-bit IP address, we have 8 bits assigned in the class A as a network, 24 bits assigned as a host in class A, 16 bits assigned as a network bits in class B, 16 bit, another remaining 16 bits assigned as a host in class B, and 24 bits assigned as a network in class C. 24, this is 24, and only 8 bits assigned in class C as a host. This is network. So this is nothing but the default assignments of the IP addressing informations. Class A, Class B, Class C. Class A has got 8-bit network number. Class B has got 16-bit network number. Class C has got 24-bit network number. So the same we can take it as in reverse. Class A has got 24-bit host number. Class B has got 16-bit host number. And class C has got only 8-bit host number. That's the only thing. So that is what network number assigned by ARIN. ARIN means it's also another authority. And H is a host number. That's it. Somebody is coming up. Okay. Let's go to the next slide. IP address classes, the same thing. Class A, see that 8-bit of network number, 8-bit network number, and 24 bits host number. And class B, 8 plus 8. 16-bit network number, 16-bit host number. And class C, 8, 8, 8. 24-bit network number and 8-bit host number. This is what the representation. You should need to understand this. This is nothing but the default. I should say that it's a default. Default representation has been shown in this figure. Let's go to the next slide. So when we talk about the class A network, 24 bits of hosts are possible. 24 bits of hosts is possible. Means 2 power 24 I just need to calculate. When I am calculating 2 power 24, the numbers will be coming as a 6. Because of -2 I just need to make it. -2 means in the sense, one will go for a network number, one will go for a broadcast address. So it is actually 16777 but -2 will be 214 like. So in class B, 16-bit for the hosts, 2 power 16 minus 2, 65, 534 hosts possible. And in class C, 8 bits, 2 power 8, 256 will come, but we will reduce it to -2. -2, why we are doing it? -2, we are going into one will go for the network address and another one will go for the broadcast address, which we will not be able to assign it to any hosts or any servers or any routers, any switches, anything, nothing. No entity can have a network number and no entity can have broadcast address. That's why we will omit these two. That's why we are doing always -2. When we are calculating the host address, we'll just do the -2 from the host bits. Then we will be getting the clear picture of the maximum host available per network. So let's go to the next slide. I guess you must be clear about this. IP address as the decimal numbers. How do they represent? Class A is starting with a 0. See that? And the binary range is this much. 0 to 127 will be the class A. And the class B is starting with the 128 to 191. And the class C will start from 192 to 223. Means the first octet we are talking about. If I am saying that, once again. So if I am saying that 10.1.1.1 means I'll just see only the first octet. 172.16.1.1 and 192.168.1.1. The first bit, first byte information I will just see always 10, 172, 192. When I am seeing it as a first octet in the sense, by seeing the first octet, if it is falling in this range 0 to 127, so this 10 is nothing but a class A address. And the 172 it is coming because see, class B is having the range between the 172, 128 to 191. So I will make it as this is as a class B. And the class C, because it is starting with the 192, I can just say class C. So first octet or the first byte information, if you just see that, you can just say which class it belongs to. Okay, I guess now you understood this. So 127 we will be normally using it for the loopback testing and other things. We will just see 127.1.1.1. We will be always pinging that. When we are pinging this, your local host will be responding back. Means your TCP IP stack which is installed in your computer or in your device, maybe router, switch or anything, which will be responding it back with the full 5 replies should come back when you're pinging it. Means your TCP IP stack has been installed properly. That's the meaning of it. Let's go to the next slide. Private addresses. Private addresses and public addresses. I just need to talk about this. Public addresses means which we will be purchasing it. Purchasing in the sense either statically we will purchase or dynamically we will purchase. Dynamic purchase in the sense whenever you are connecting to the internet through your mobile phone or through the broadband connection or from your official connections or something when you're going for it. So that is a dynamic number assigned. Dynamic number in the sense when you disconnect from the internet at that moment, the IP address which you were holding it will be released. It will not be yours anymore. That's why it is called as a dynamic. And it is a temporary connection which is given for you. The same IP can be assigned to the other person, whoever is just connected. And static public address has also been there. Means you will be purchasing that address and you will be holding it for your own websites or something, because every other website requires the public address has to be there. Whenever we are try to doing the NS lookup, when we try to see the public address assigned for a site or something like that, we will be getting it from out of this range. The range will not be the same. These are all the ranges are called as the private ranges. When we are assigning the addresses from the range of 10 and range of 172 to 172.31 and 190 to 168, these are all called as a private addresses. Private. Private means we are not going to pay any money to anybody. We are okay to use, we are free to use these addresses in our networks only. And moreover, these network addresses cannot be routed on the internet. That is also more important. This whole range is not allowed to be routed on the internet. You don't face any kind of these addresses are assigned to anyone in the internet, because this is used only for private purpose. Means in your company we will be giving the DHCP servers to throw these addresses to the clients like this. Whenever a client connected the DHCP server, they will be getting any one of this IP. Means to take it as, this is also again take it as a dynamic IP only. There will be a lease period will be given for that. Until then that person will be using these addresses. So like this is given for the persons which is being given on this. So that is called the private addresses. These private addresses are free to use. Let me write down so it will be understand. You will understand. Free to use. You are not paying any money to anyone at all. Free to use. And public addresses other than this range, whatever it is the addresses which you are seeing the numbers, those are all public only. Those public addresses cannot be utilized in our own local network because they are sold to someone else. Even if you assign it wrongly, it may be reporting from the ISP that you are using some different range which is not supported at all, like that. So we have to go and purchase the certain IP range or something so that you can use it in our own network. And let us go to the next slide. Obtaining an IP address. How are you getting an IP address? Static addressing. That's what I was telling. Each individual device must be configured with an IP address. We will go to the Windows 10 or Linux station or a router interface, something like that. We will just configure it with a command IP address. Or we will be configuring it through the network parameters, something like that. We'll do. That is a static addressing. Manually going and accessing, assigning the addresses. There are many other ways of assigning the addresses also. That is called as dynamic addressing. The dynamic addressing can be done by this many ways. Sorry, this many ways we can assign. One is RARP, that is Reverse Address Resolution Protocol. Next one is Bootstrap Protocol. The other one is everyone knows that DHCP, Dynamic Host Configuration Protocol. And the DHCP sequence we will be seeing it, and how the ARP is working we'll see. And ARP, how does it working with the same subnet also we'll see. Means actually the addressing part like RARP is one way, BootP is another way, DHCP is another way. There are three ways we can assign the IPs to the clients. That is what we are going to see in the next slides. RARP. How does the RARP is working? Reverse Address Resolution Protocol. Reverse Address Resolution Protocol is nothing but the source initiates the RARP request, which helps it detects its own IP address. Nothing but when your station, if it is not configured with an IP address statically, and it tries to reach the DHCP server or RARP server, whatever it may be, you can call it as. When it tries to reach, it will be raising a request call as RARP through the protocol RARP. When it is raising the RARP, when it is raising the RARP, it will be sending its own MAC address. Okay. When it is sending the MAC address on it, saying that I am having this MAC address, I need an IP address. Why the IP address is so important? So that then only it will be, somebody is asking question, need to leave for urgent work. No problem. Anyway, Swapnil, I will be, sharing this, recording to all. At the time you can get that, no problem. Okay, so Reverse Address Resolution Protocol, RARP. It's nothing but like that. We can just say like a DSCP request only, we can just say. So RARP request has been sent to receive an IP over the network. So RARP server will be sending it through the IP address for the people. Like everyone is having their MAC. See that MAC address, destination, source, something like that. IP address. What is the source? No. RARP request message. What is my IP address? So this guy is asking this source guy is asking about that. What is my IP address? Please assign me an IP address. So that when he's trying to receive an IP address, he will be sending his own MAC address to this. Then the RARP server will come back and say that this is going to be your MAC address like that. Then this is going to be your IP address like that. When the IP address assigned against one MAC address, the same IP address will not be repeated to the other guy. So it is a one-time assignment like that. So it has been maintained by the machines that the duplicacy will not be done between the systems. And the next is a BootP. Bootstrap protocol operates in a client-server environment and only requires a single packet exchange to obtain IP information. BootP packets can include the IP address as well as the address of a router, the address of a server, and vendor-specific information. This is also one other form that BootP IP we can get that. And DSCP. Normally we use the DSCP server to assign the IP addresses to our clients in our network. Dynamic host configuration protocol. Always a host to obtain an IP address using a defined range of IP addresses on a DSCP server. As hosts come online, they contact the DSCP server and request an address. This is the initialization sequence that is happening. What is the sequence? First, client booting. We are booting the PC. Initializing state. And the initializing state, it will try to discover. That is called as a D. It is called as a D. D for discover. Okay. And then it comes to the when it is discovering that. Discovering means through sending the RARP request and other things, it will try to discover who is the DSCP server. Then when it is requesting, it will go as R packet will go. Discovering it, then it is requesting its own IP. When it is requesting its own IP, it will be sending its own MAC address to the server. Then the acknowledgement has come. It's called as a DORA process, like that. They normally call it as a DORA process. DORA process. So it's like a discover, request, and acknowledgement. At the time of acknowledgement, the IP address has been received to the client. So this is how the DSCP is offering. So once the DSCP offered an IP address to a particular PC, that particular PC MAC address has been registered against the IP address so that the duplicacy will not happen. Means the same IP will not be given to someone else. For example, the station A has got a MAC address of AAA111 and it has been assigned with the IP address of 1111 by the DSCP server. When B comes with the MAC address of BBB222 and he will be assigned the IP as 1112 like this. It will not assign 1. The 1 will not get repeated. That's what I was telling. So this is the DORA process and let's see the next slide. ARP. How the ARP is working? ARP means Address Resolution Protocol. Why do we require ARP? ARP requires to understand what is the destination IPs. Whenever there is a packet has been formed, the packet will contain the source IP, destination IP, and source MAC and destination MAC. That is a full packet. I can just say that. Full packet in the sense I will say source MAC has to be there, and the destination MAC has to be there. Source IP should be there, and destination IP should be there. Then only the packet will get completed properly. Whenever a station tries to send the packet, okay, whenever the station tries to send a packet to the destination, so take it as this is a source guy and he is a destination. They are in same network only. See that 192.199. Sorry, he is in a different one. Okay. Anyway, the router is required for this. Anyway, whenever it is sending it when it is sending it, we will see the same network ARP also. When the destination is this, then it will be raising an ARP request. ARP request will always go as a broadcast only. Means what the raising guy will be saying it. See, my IP is this. My what is that? My IP is this. My MAC is this. But I would like to know the destination IP and destination MAC. Destination IP maybe it be there in that, but destination MAC is unknown. So destination MAC will be determined by the OLF. We will just see that in the next slides. When it is sending the packet like that without a complete entry, means the destination MAC will not be there. Whoever is receiving that particular packet, if the IP address is matching with that, and they will be providing their own MAC address. So that MAC address will be filled in with that. So entire communication will be happening on that. That is our communication which is happening between the systems. Yeah, this is within the subnet C. So this is a source and this is a destination. The source is sending that. I would like to know about the destination IP of this, destination MAC of this, sorry, destination MAC. Source is 2233 and the destination is 22126. When I am pinging from source to destination, I will be pinging the address like ping 197.15.22.126 like that. At the time, this source will be raising an ARP packet. The ARP packet will be containing the destination MAC as a 0, means like all ones. Everyone will be receiving it, but only the destination will respond, means because the IP address is matching. When the IP address is matching, it will supply its own MAC address to the source. Then the source will directly talk to the destination only. It will not send any more broadcasts. So ARP will be sent as a broadcast. After the ARP resolving has happened between the stations, there will be a unicast. Unicast means one-on-one communication will happen from source to destination. That is what the ARP operation like this. This ARP process, how does it work? Send the data to the device. Is the MAC address in my ARP cache? Yes means it will directly send the data. No means it will send an ARP request. It will send an ARP request, get an ARP reply, then send the data. Like that. There will be a small subroutine will be there when there is no MAC addresses in our database or something. Okay, some important point we come into that. We are all talking about the subnetting, IP addresses and subnetting and all. IP addresses, which we know everyone that there is a 3 classes of there and the ABC has been there, and we are going to do some kind of a subnetting on this one. Why do we do the subnetting? And what is the purpose of subnetting in the sense? When your network is out of the range in the sense you will not be able to assign any more addresses to the people. And when your network is keep on growing, means you need to address it some more PCs on the different cities as well. And your companies keep on growing like anything. It's crossing across multiple boundaries as well. So at that time, you just need to address all the people like. So when you are going for this kind of an addressing, which you already have some IP addresses in your hand, may go out of hand. So at that time, you require to do the subnetting. The subnetting is to create a subnet address. A network administrator borrows the bits from the original host portion and designates them as the subnet field. So we will be seeing something on that, how to do the subnetting on this practicing. I will take up that class C subnetting first, and I will be doing the class B as well, class A as well. Like if you require that, if you like to see that, it is not so hard and it is not so easy also. It requires some patience and it requires some mathematical skills. What mathematical skills you require? You just need to know that how to multiply by 2 and how to divide by 2. These 2 things, if you know that, you will be able to do the subnetting easily. Not a problem at all. And see, this is a subnetting. Network, subnet, and host. So there is a network numbers are already been assigned. See 888, it's been assigned. But the host, from the host, we are going to receive some bits on this. So better I can just directly go and start doing the subnetting so that you will understand that. Let me start my, let me do the, sorry. Let me do that. Subnetting. First, let us start with the class C subnetting. The class C in the sense I just say 202.178.168.123.147, something the address. So by default, sorry. This is a class C address. Definitely we know that because the 202 is nothing but it is falling in the range of, what is that, 192 to 223, right? This is what that. Let me make it out that for your example, class A will be starting from 1 to 127. Class B 126 also you can do, 128 to 191, and the class C will be like 192 to 223, like this. So this we know. So we know that. So this is what nothing but the class A, class B, and class C. So now what I assigned is like class C address. In this class C address, as usual, the default mask has been assigned. Default mask is assigned. Default mask in the sense it is going to be like a 24-bit networks and 8-bit hosts. 8-bit hosts. This is nothing but like /24, I can just say. /24 is nothing but that. But when I am doing the subnetting in the sense, what I do, I will not leave all the 8-bit for the host. Let me write down here, it will be easy for you. N, this is the host. What I will do when I am doing the subnetting in the sense, I will be, I will not give all the host bits to do, they'll join the entire host or something. I will just change some number here. I will give it like 224. If I am doing that, this is actually not the host. Some bits are assigned to the host and some bits are taken to the network. Getting it? So some bits are assigned to the host, some bits are, how do I assign that which bits has gone to the network and which bits are remaining with the host in the sense? I will do the 224. I will convert it to the binary. Let me take the calculator, no worries. We will do that, like programmer will do. 224. So this is the 224. You can just see 3 ones and 0 and all 0. 3 ones, 1, 1, 1, 0, 1, 2, 2, 3, 4. This is 224. Then I have to do the conversion to the binary of 147 also. Let me do the 147. 147. Binary is what? 1001 and 0011. So I will write it here. 001 and 0011. That's all. Now it is come. So what I need to do, I just need to do some multiplication operation. Either I will be doing a multiplication or I'll just do the ANDing. ANDing in the sense it's nothing but an application. It's nothing but multiplication only. 1 into 1 is 1. 1 into 0 is 0. 0, 0, 0, 0. So in this one, whatever the first number which I am receiving it, take it as that entire thing. Entire thing in the sense. So what is the first number? This is the 8th octet. I can just say 2 power 0, 2 power 1. And like that it goes on. Let me tell you that. It's 8 bits are there in our case. In our case, we have 8 bits, 2 power 7. It will take like 2 power 7 will be 128. And 2 power 6 is 64. And 2 power 5 is 32. And 2 power 4 is nothing but 16. 2 power 3 is 8. And 2 power 2 is 4. 2 to the raise of 1 is nothing but 2. And 2 to the raise 0. Anything power 0 is 1. So when I am adding this, it will come like about 255. It will be 255 only. So that's why we are giving always a mask information as 255 only always. An IP address without a mask is like an invalid one. So when I just see this 2 power 7, now we can just say 2 power 0, 1, 2, 3, 4, 5, 6, 7. So 2 power 7 is a 128. 128 is nothing but a subnet ID. Just say subnet ID. So subnet ID in the sense, what should be the subnet ID here? If I like to write it completely, 202.168 dot 123 dot 128 is a subnet ID, and the mask will be like this: 255 dot 255 dot 255 dot 224. This is the mask information. This is subnet mask, and this is a network ID. So this is how it's been written. So now what I can do, this 128 as usual, I will not be able to assign it to any host or something like that. I can start from the number 1, means like 1 0 0 0 0 0 0 1. From here I will be able to start assigning it. 129. This is the first host which I can assign it. Before going into the host calculation, we just need to know that how many bits has been taken for subnetting. Number ones are nothing but the subnet bits. Host, I'm telling that the bits we are saying now, n, these are all host. So there are 3 bits has been taken for a subnetting, and 5 bits has been left out for the host. You can just say 3 bits. So when you try to calculate it, the numbers will be keep on going on 129, 130, something like that. It will be keep on going 130 and 131, like 132, like that, keep on going. First host, second host, third host, fourth host, like that. It will keep on going it. Then when you try to see that what is the broadcast address is going to be, in the sense, there is a small trick is in that. We just need to make all the host bits as 1. That's all. So what is the network bit here? The network bits are like 100 only. Then all the 5 bits, if I'm making it to the all ones, that will become the broadcast address for this subnet. So 128 plus, I just need to add this. 6th position is not there, 5th position is not there. 4 3 2 1, like that. 5 4 5 4 3 2 1. 5 4 3 2 1 in the sense 32 plus 16. I can just do it with the calculator. 32 plus 16. Oh, sorry. Let me take it as like normal calculator. 32 plus 16 plus 8 plus 4 plus 2 and plus 1. This will be 63. So 63, I just need to add 128 plus 63. How much will come? Let me do 128 plus 63. 191. 191 is my broadcast address. It's a broadcast address. So next to the broadcast address will be the next network. Simply we can just go with it. 192 is the next network number. Next network ID means the next network ID will be like this. I can make it in this way. It's simpler. It will be 192. Like this, it will be keep on going on a chunks like that. The chunks will be of how many bits, like that it goes. So 3 network bits which we taken from the host. So 2 power 3 will be 2 power 3 is equivalent to 2 into 2 into 2 into 2. Like this. How much it is? 8. 8 subnets possible. And 2 power 5, sorry, 2 power 5 minus 2 we have to do. So 2 power 5 in the sense like 2 into 2 into 2 into 2. 5 times I just need to do. How much it is coming? 4, 8, 16, 32. 32 minus 2. That will be 30. 30 hosts possible. 8 subnets and 30 hosts possible when I pick 3 bits of subnetting. Someone else is, I guess, want to join, I guess. I don't know. Yeah, he's there. Okay. So when I am taking the 3 bits of subnetting, I will be able to create 8 subnets, and each subnet I can have the 30 hosts on this. Means the host will go like this with the mask. 129, what is that? 202.168.123.129 with the mask of 224, like that. So without a mask, an IP address is invalid. And why we are doing the subnetting, in the sense, to do the subnetting only we require to have the more subnets can be created, so that the more the more branches can be made with that subnetting. Let me do one more example so you'll understand easily. 200.199.198.197. Something like that I just do. 255.255.255.240. Let me take this time. 240, let me need to convert that into the binary first. It's a simple method. Let me go to the programmer. 240. What is that? 4 ones and 4 zeros. 1, 2, 3, 4. Then all zeros. 197, I just need to do the conversion. Let me clear this. Then I'll do 197. 1100 0101. 1100 0101. 0101. Then as usual, I'll be doing the ANDing operations. Then now it will become 1, 1. 1 into 1 is 1. 1 into 1 is 1. 1 into 0 is 0, 0, 0, 0, 0, 0. All 0. What will be the network number? 128 plus 32. Here it is. 128 plus 64 will be 192. So 192 is a subnet ID. Then the host will be starting from like that 193. Then 194. Then 195. Like that it will keep on going on. So I just need to find out the broadcast ID. How do I find the broadcast ID? Here there are 4 network bits are there, so I just need to take it as it is 1100. Then all things I will make it as like all the hosts. Here I just see this is the network number. Network bits has been taken. N and N. This is a H. So all host bits I will make it as like a 1. So now I just need to convert this into the decimal. Decimal, if I'm converting 192 is been already there because of the 2 bits are there. So along with it, I will have to do that 8421. 8421 I just need to add. 8 means 82 plus 10, 14, 15. I just need to add 15. 192 plus 15. Let me do that. Let me clear this and I'll go back to the standard 192 plus 15. 207. 207 is the broadcast ID. Sorry, it's a broadcast ID. And the 208 will be the next network. Like this. So now let us calculate the how many subnets are possible on this one. 2 raised to 4. Because 4 subnets I taken it. 4 bits I taken it. 2 into 2 into 2 into 2. Like that. How much will come? 16 will come. So 16 subnets possible. And 2 power 4 again. This time I will do that 2 into 2 into 2 into 2. But 16 will come. I just need to minimize it like minus it to 2. So 14 hosts are possible. So when I am taking the 4 bits of subnetting, I will be able to get 16 subnets and 14 hosts per subnet on this. This we are doing it on class C. Got it? So this is an example of that. If you like to have some more examples, you can just go to do that. And I can give you some examples also. If somebody would like to ask any questions on this, okay, I can answer that. You have any questions on this subnetting? Hello? Anybody? No questions as such? Ask any question, anything on subnetting side, you can ask me, no issues. Let me save this on the example. Then let me open that, the class B example also. So there you will be able to see that one. So in this class B and class A subnetting example, I taken one subnet of the class B. This is a class B because it is starting with the 172, 16.230.45. And the class B has got the 16 bit only. But what I'm doing it, I'm adding some more bits to this. 240 I added that. 240 as usual, there will be 4 network bits. I can just make it out here. N, 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 and this all host. Here, what is the problem is that because it's already 16 bits are assigned for network, plus 4 bits we are taking here, plus 4 bits we are taking it. Okay. 248 taken it. 224 is the one, that 12 host bits, I guess it's something wrong. You can just see the class A example as well. Like that, we can see many examples on this. It's a bit problematic here, I guess. 240, it's not a 240. 239, 240 is the next network. 12 host bits. Yeah, 12 host bits only. 4 plus 8. 12 host bits are coming on this. Not a problem, it's a correct one. And the network bits are 2 power 4 only. So what is the problem is here in the sense, because we are crossing across this boundary. This is 8 is already occupied. Here 8 is occupied, 16. Plus only the 4 we taken it. Rest of the 12 bits are still available for the hosts. Accordingly, we just need to calculate. 2 power 12 will be 4096 hosts. And minus 2 when you take that, 4094 usable host will come up. And because of the 4 network bits, I will be having the 16 bits subnets possible on this. And the class A example also the same way we can solve it out. Not a problem. And 10.174.124.188, this is the one. By default, the class A has got the 8-bit, the default mask assigned. But here we taken some more bits, 2 more bits we taken it. Here I can just say N and N. So 2 bits are extra taken and 6 bits are left out for the host, but host bits are so much now here. And here 6, 8 plus 8, 16 plus 6, it will be 22 host bits are there, and 2 network, so 2 subnet bits. And when you calculate that, 128 will be the subnet ID. And the network ID will be coming like this, 128.0.0. And the first host will be 128.0.1. And the last host will be 191.255.254. And broadcast ID and the next network ID, like that we can keep on going on. So it's not so harder to work on subnetting, it's easier. It's if you do the handful of exercises, it's very easy for you to understand the subnetting, not a big problem at all. And the class C will be quite easier to do that because it is in a class last subnet only we are touching on. But in the class B and the class A, it will be a bit difficult because we need to understand that how many bits has been borrowed and how many bits has been given for the hosts to retain, like that. So accordingly, we just need to calculate that. Okay, I guess we crossed more than an hour. And if you have any questions, you can definitely ask me. Now I'm open to the questions. Let me come back to the slides here. And this is you can see my contact details on this screen. You can contact me for any kind of sessions as well. I used to take for a cloud certifications, and I will be doing something on F5 load balancers. Firewalls I do. Cisco definitely I do that, CCNA, CCNP on security as well as the routing, switching, and the service provider environment I'll be working on. So any kind of solutions or trainings which you're looking for, you can come back to me on these numbers. WhatsApp number I given there, and email address has been given. And I have given my office. Perhaps my YouTube channel has also been there. So in this YouTube channel, you can subscribe to that. You can get the latest videos on this one. So I'll be planning to give some more videos as well. So if you have any questions on this subnetting or TCP, something you can ask me any questions on this. I'm ready to answer you. Hello, people, are you still there? I guess some more people are there. You can ask me any questions, not a problem. I can answer you. Just unmute your mic and you can ask any questions, no issues. And I would like to have the email addresses and phone numbers of the people who attended these sessions, so that I will be sending you the slides to you, so you can use it. Excuse me. People are there?
Yes, sir. I am here, sir.
Yeah,
Rajesh
okay.
here.
You can give me your email address or phone number, something like that. Email address is enough. I can send you some mails to the people, like, all
So I
the chatting.
the chat box.
Yes, yes. Please put it on the chat. I can get that. Everyone can give me the email address. I'll not disturb you. Don't worry. Like normal institute people will be calling you like that. Okay. Okay. And
Sir, if you remember, I am from Airport Authority of India. You have taken a session for us.
okay. Maybe, yeah. Okay. Understand. Yes, because I'm giving a lot of sessions on that. So maybe
Yeah,
there's
you
so
hosted
many.
from the Aviation Academy, Indian Aviation Academy. You have
Yes,
taken the class.
yes, I understand. Maybe in the last couple of months before you attended, or how before that?
Yeah, yeah. I think 2-3 months before.
3 months before. Okay, nice. So Rajesh has given, and Dhiran has given. Somebody, people can give it. Other people also can give it. Yeah, because it's time is getting late.
Hello, Ramnath.
Yes.
Yeah. So, do you have any session or video like regarding TCP IP in detail? Like, what are the flags? How it is working? How the retransmission is happen? If what happen if any packet loss? Like that.
So I just need to make it in that way, because actually I look for like people who are in the support side to understand about the TCP in subnetting. Another thing, it's more informational side. If you look for complete deeper through the programming side or something like that, I can share some documents which are there with me. I can share it to you. You can give me your email
Yeah.
address.
I have shared it on the chat. It would be better because I need I have some interviews in upcoming weeks in regarding the tech team,
Okay.
and it is basically for the product based company or that are looking for a firewall tech person.
Ah,
If I can go through that articles, then it would be better for my interview. So
yes,
that's the reason.
definitely I share that. And moreover, whenever we are doing the F5 load balancers and security related topics and all, that time I will be asking about, I'll be talking about this TCP inside, because rip apart the complete packet and we just need to do that. As a separate session, I have not done that. It is going along with
No,
some
it is
sessions.
not a separate session. If you have any link or any documents like that, you can also
Yeah,
go through that link.
I can, yes, I can give the link or something. I have some documents which I can share it with you. Please share your email address in the chat box.
I have already shared it with you. It's modahiran@hotmail.com.
Just type it now, because I am having so many contacts, so I may lose it all. Better you can put it on this one so I can remember. Yeah.
Okay.
It will not be shared to anyone else. It will be like, I will keep all the privacy intact. No worries at all. I will not share with the people, other people as well. No worries. All your information will be intact only. I will be talking to the particular persons only. And you can
I
moreover.
will send you on the WhatsApp group as well. I will send you my email address and contact number in WhatsApp group as well to you personally.
Oh, okay. Okay, then that's not a problem. I will get back to you on that. So,
Yeah.
any more questions from your side, so that we can go ahead and can have a Q&A sessions, or we can close this session because it is near about reaching 2 hours. I guess so.
Yeah.
I'm not sir.
Uh,
Sir, I'm Rajesh here. I just want to ask. I am getting the links for all your training sessions in my personal WhatsApp number.
okay.
So, can I forward it to my other colleagues so that if anybody is interested, can join it?
Definitely, this is open for all the people only. That's why I'm putting it on all the groups as well. Network group is many groups are there. Firewall groups are. I used to ask the
Oh,
people, like, whenever you're getting something like intimation from my side, please share it with all your colleagues and friends and everywhere. Everyone can join.
okay,
It's open completely.
okay.
Okay,
Thank you, sir.
thank you very much. Thank you. I just raised up this question. Nice. Oh, thank you very much. And so, any other queries from your side? Please ask me. I'm ready to answer you. But not only this TCP and other things, I have some other better good videos of the SDN, which recently I done that software defined networking, and other things I'm planning for the BGP and MPLS and other things I'm planning for next week or something. And I go with an FI and checkpoint and other things and all. Please do connect with me so that you will be getting all the videos from my side. And you can subscribe to my channel. Every other video, whichever I do, that I'll post it on the YouTube in a 3 or 4 days, a couple of times, like that, whenever I'm getting time. But within a week, definitely I will be uploading that. So you can subscribe to that, so you will get the update without having any problems or something. Okay, then if you are not having any much questions and all, we can go ahead and close this session. And I will send all the informations to this video as well as the slides to the people who are attended, and as well as I will share it on the public WhatsApp groups as well. Thanks for joining. Thanks for all.
Yeah. Thank you. Thank you so much.
Thank you. Thank you so much.
So, bye. Thank you.
Bye bye.